Learning objectives. In this chapter, the user will learn the following in detail. Main memory as source of error and their rectification. Conflicting DLL as source of error and their rectification. Unknown interface as source of error and their rectification. What is DLL? Dynamic Link Library, DLL, is Microsoft's implementation of the shared library concept. A DLL file contains code and data that can be used by multiple programs at the same time, hence it promotes code reuse and modularization. DLLs, dynamic link libraries, are small files that are part of the operating system of your computer. Every DLL obviously has its own job to do, but the common feature of them all is that they provide one function to several programs and operations that are part of the operating system itself. So instead of 5 or 10 programs all having a file within them that does the same job for each, you have one DLL as a separate standalone file that all of the 5 or 10 programs will call up as and when needed. Dynamic linking is a mechanism that links applications to libraries at runtime. The libraries remain in their own files and are not copied into the executable files of the applications. DLLs link to an application when the application is run, rather than when it is created. DLLs may contain links to other DLLs. Many times DLLs are placed in files with different extensions such as .exe, .drv, or .dll. Advantages of DLL. DLL files don't get loaded into the RAM together with the main program. They do not occupy space unless required. When a DLL file is needed, it is loaded and run. For example, as long as a user of Microsoft Word is editing a document, the printer DLL file is not required in RAM. If the user decides to print the document, then the Word application causes the printer DLL file to be loaded and run. DLL helps promote developing modular programs. It helps to develop large programs that require multiple language versions or a program that requires modular architecture. An example of a modular program is an accounting program having many modules that can be dynamically loaded at runtime. Easy to deploy and install. When a function within a DLL needs an update or a fix, the deployment and installation of the DLL does not require the program to be relinked with the DLL. Additionally, if multiple programs use the same DLL, then all of them get benefited from the update or fix. If you use a third-party DLL that is regularly updated or fixed. Applications and DLLs can link to other DLLs automatically if the DLL linkage is specified in the import section of the module definition file as part of the compile. Else, you can explicitly load them using the Windows Load Library function. Important DLL files for programming. COM DLG32.dll controls the dialog boxes. GD132.dll contains numerous functions for drawing graphics, displaying text, and managing fonts. Kernel32.dll contains hundreds of functions for the management of memory and various processes. User32.dll contains numerous user interface functions involved in the creation of program windows and their interactions with each other. Types of DLLs. Load time dynamic linking. Runtime dynamic linking. Load time dynamic linking. An application makes explicit calls to the exported DLL functions like local functions. To use load time dynamic linking, provide a header, .h file, and an import library, .lib file, when you compile and link the application. The linker will provide the system with the information that is required to load the DLL and resolve the exported DLL function locations at load time. Runtime dynamic linking. In runtime dynamic linking, an application calls either the load library function or the load library AX function to load the DLL at runtime. After the DLL is successfully loaded, use the getProcAddress function to obtain the address of the exported DLL function that you want to call. When you use a runtime dynamic linking, you do not need an import library file. The following list describes the application criteria for choosing between load time dynamic linking and runtime dynamic linking. If the initial startup performance of the application is important, then use runtime dynamic linking. 1. In load time dynamic linking, the exported DLL functions are like local functions. It helps you call these functions easily. 2. Application logic. In runtime dynamic linking, an application branch to load different modules as required. This is important when you develop multiple language versions. Running conflicting DLLs simultaneously. The solutions here consist of having different copies of the same DLLs for each application, both on disk and in memory. An easy manual solution to conflicts was placing the different versions of the problem DLL into the application folders rather than on a common system-wide folder. This works in general as long as the application is 32-bit or 64-bit and that the DLS does not use shared memory. In the case of 16-bit applications, the two applications cannot be executed simultaneously on a 16-bit platform or on the same 16-bit virtual machine under a 32-bit operating system. OLE prevented this before Windows 98 SE 2000 because earlier versions of Windows had a single registry of COM objects for all applications. Windows 98 SE 2000 introduced a solution called side-by-side assembly, which loads separate copies of DLLs for each application that requires them and thus allows applications that require conflicting DLLs to run simultaneously. This approach eliminates conflicts by allowing applications to load unique versions of a module into their address space while preserving the primary benefit of sharing DLLs between applications, reducing memory use by using memory mapping technique to share common code between different processes that do still use the same module. DLLs using shared data between multiple processes cannot take this approach. One negative side effect is that the orphaned instances of DLLs may not be updated during automated processes. Errors related with main memory. How to check main memory RAM errors and how to fix it. The physical memory, also known as RAM, random access memory, is one of the most important components of a computer system as it stores data for running application as well as transitional data from one component to the other. RAM errors may be caused by several factors. Improper configuration in BIOS is probably the most common source of RAM errors. A bugged BIOS or operating system can also be a cause as well as physical flaws in the chips themselves. If you experience one of the following symptoms, you should consider checking your RAM for errors. Blue screens of death, black screens, unexpected system restarts, unexpected system shutdowns, slow computer and/or system startup, weird sounds coming from the computer case. For example, Windows Vista and Windows 7 have an inbuilt in-memory diagnostic tool. It is mostly tuned to find physical flaws in memory chips and very rarely manages to detect logical flaws such as improper configuration or poor BIOS management. To use this tool, 1. Press the Start button in the Search Programs and Files, Write Memory Diagnostic tool. 2. The result of that search returns is the Window Memory Diagnostic tool. 3. The memory can't be properly tested while the system is running. 4. Therefore, you must schedule the test for the next restart. 5. This diagnostic tool contains several tests. Example, MEMTest86. Use some third-party specialized tests such as MEMTest86 for more accurate results. MEMTest86 comes in two versions, one that is bootable and runs before the system startup and one that runs in parallel with the system. It can only test blocks of memory which are not used by any application. The first version, bootable image, is the one you should be using if you want an accurate testing of the memory. It contains 9 tests divided into 3 big groups. The first 4 tests will look for physical flaws in the chips. Tests 5 through 7 will look for logical flaws in the memory configuration. Tests 8 and 9, which can take a day or two to complete, depending on the amount of RAM, check for stress weaknesses as well as physical and logical flaws. The last two tests usually find errors that the first tests would have discovered anyway. So it is not mandatory to run them. Once an error is found, the test stops. It is enough to have one error for your memory to not work properly and pose a threat to the entire system. Depending on the test that found the error, there are different ways of fixing the error. Note that if you use several memory chips, it is impossible for the test to tell in which chip the error was found. Therefore, it is a good idea to test each chip independently and then in combinations till you have tested every possible configuration. Troubleshooting errors. Regardless of which test found the error, there is basic troubleshooting that should be done. First, you should update your BIOS. That may sound dangerous, but BIOS can easily be updated through automated applications that run in a Windows environment. These applications can be found on the website of the motherboard manufacturer or on the CD that came with your motherboard. After the BIOS is updated, you need to enter the BIOS setup and manually set the RAM timings, frequency, and voltage to their appropriate values. You can find these values on the chip manufacturer website or on the documentation that came with the chips. Once you've done these two steps, run the test again. If errors are still found, regardless of test, you need to replace the chips. Example: Parasoft. Parasoft Insure++ identifies difficult-to-track programming and memory access errors such as memory corruption, memory leaks, access outside of array bounds, invalid pointers, and more to ensure the integrity of memory usage. It performs runtime error detection during application testing, for example, as manual, scripted, or automated system-level tests are performed, or while it executes unit tests. As the application executes, we analyze it, then report errors that actually occurred during execution. The coverage of these tests can be tracked and reported. Categories of defects detected include crashes, database, exceptions, functional errors, file I/O, GUI, memory, network, optimization, portability, security, servlets, threads and synchronization. Lightweight error detection for embedded. Since the instrumentation used to perform runtime error detection is lightweight, it is suitable for running on the target board, simulator, or host for embedded testing. This helps embedded teams automatically identify serious runtime defects such as memory leaks, null pointers, uninitialized memory, and buffer overflows. The collected problems are presented directly in the developer's IDE with the details required to understand and fix the problem, including memory block size, array index, allocation, deallocation stack, trace, etc. Work with web, cloud, SOA applications. For web, cloud, and SOA applications, Parasoft can perform runtime error detection as it runs your automated functional tests or penetration tests. Each reported error is correlated with the functional test that was being run when the error was detected. This allows you to trace each reported error to particular use cases against your application. Beyond runtime error detection. Runtime error detection is a critical component of a comprehensive quality process. The most effective quality processes involve a combination of test and analysis practices embedded throughout the SDLC. Parasoft runtime error detection is fully integrated with a broad range of complementary capabilities, including peer review, unit testing, end-to-end functional and load testing, and service virtualization. For organizations ready to take the next step towards ensuring that quality software is produced consistently and efficiently, Parasoft Development Testing Platform integrates policy-driven project management with Parasoft Test automated defect prevention and end-to-end QA testing. This ensures predictable project outcomes while driving unprecedented levels of productivity and application quality. External interfaces. External interfaces are used to communicate with the world. These include devices, actuators, sensors, input terminals, printers, and communication lines. The primary design criterion for an interface with the outside world should be robustness. All external interfaces, human or machine, should employ a protocol. The protocol may be wrong or incorrectly implemented. External interface bugs are invalid timing or sequence assumptions related to external signals, misunderstanding external input or output formats, insufficient tolerance to bad input data. Unknown interface errors. The unknown interface error message is the numerical data format of the error message generated. This is the normal error message format used by Microsoft Windows as well as other Windows-compatible software and device driver suppliers. This computer code is used by the vendor to identify the error code cost. The unknown interface.error message features a numeric value as well as a brief technical description. In some cases, the error code could have extra factors in unknown interface.data format. The further number and letter code will be the location of the memory locations in which the guidelines are filled at the time of the error. What causes unknown interface.error message? An unknown interface.error code may be caused by Microsoft Windows system data file damage. Damaged system files are usually a real risk to the well-being of your system. There are quite a few situations that can have resulted in file errors. Partial installation, an incomplete file erasure, incorrect deletion of applications or devices. It could also be caused if the system is infected by a virus or adware spyware attack or by an incorrect shutdown of the computer. Many of the preceding actions can end up in the deletion or data corruption of Windows system data files. That corrupted system files will lead to missing and wrongly connected documents and data files required for the proper working of the application. Guidelines on how to simply address unknown interface.error message. There are two techniques to take care of unknown interface.error. Advanced method. Start your computer system, then sign on as the administrator. Click on the Get Started button, then click on Programs, Accessories, Tools, then select Restore. Inside the next window, select Restore My PC to an earlier time, and after that click on Next. Find the latest restore point within the Click a Restoration Date listing, then click Next. Then click the Next button in the verification screen. Restart your laptop or desktop when the rescue is finished. Beginner use method, completely automatic. Download this unknown interface.repair application. Set up software and click Scan button. Next, click the Fix Errors button in the software as soon as the diagnostic scan is completed. Reboot your PC. Otherwise, download a different unknown interface.recovery tool to rectify these type of errors. Conclusion. In this chapter, we have covered the following in detail. Main memory as source of error and their rectification. Conflicting DLL as source of error and their rectification. Unknown interface as source of error and their rectification.